Another way to remove excess heat is to cool the gas after the compression process is complete. The device that does this is called an aftercooler. Another important compressor system is its lubrication system. The main function of a compressor's lubrication system is to reduce friction between the compressor's moving parts. Lubrication also helps to cool the compressor's parts and to keep gas from leaking out of the compressor. The main parts of this lubrication system are an oil pump, a filter, a heat exchanger, and an oil injector, which is commonly called an oiler. Oil from the compressor flows into the pump. The oil is then pumped through the filter, which removes any solid particles from the oil. Next, the oil flows through the heat exchanger where it is cooled. From the heat exchanger, most of the clean, cool oil flows directly back to the compressor to lubricate some of its moving parts. But some of the oil flows to the oiler. The oiler supplies a small amount of oil to the compressor cylinder. In the cylinder, piston rings are used to maintain a seal between the piston and the cylinder. The oil lubricates the piston rings and helps seal the space between the cylinder wall and the rings. Compressed gas systems use auxiliary devices to remove oil or moisture from compressed gas and to prevent overpressurization. Two devices that are used to remove liquids from compressed gas are oil separators and demisters. Most reciprocating compressors that contain pistons use oil to lubricate the piston rings. During compression, some of the oil can become mixed in with the gas. This oil must be removed from the gas to prevent system equipment from being damaged. Oil removal is accomplished using oil separators. This illustration of an oil separator includes an inlet, a series of baffle plates, a wire mesh screen, a sump, and a gas outlet. Compressed gas that enters the oil separator passes around the baffle plates. As the gas travels around the plates, it is forced to make rapid changes in direction. A desiccant dryer uses chemicals called desiccants to remove moisture from compressed gas. Two commonly used desiccants are silica gel and activated alumina. This is a simplified illustration of one type of desiccant dryer. The desiccant is contained in two tanks. The dryer also has a gas inlet, a gas outlet, a waste gas outlet, two heating coils, and two devices that are known as four-way or reversing valves. At any particular time, one of the two tanks is said to be active. An active tank contains dry desiccant that is used to remove moisture from compressed gas. In the other tank, desiccant is being dried or regenerated. In this example, the dryer is set up so that each tank can either be an active tank or a regeneration tank, depending on the positions of the four-way valves. The desiccant in the active tank removes moisture from the gas that flows through it. Most of the dry gas leaves the dryer through the gas outlet. However, a portion of the dry gas is routed through the regeneration tank to help dry the desiccant in that tank. The heating coil in the regeneration tank is energized to heat the gas that passes through the tank. The hot gas then dries the desiccant in the tank. In this example, the gas that leaves the regeneration tank is vented to atmosphere through the waste gas outlet. Switching back and forth between tanks is often controlled by a timer. After one tank has been regenerated for a preset period of time, the timer changes the positions of the four-way valves. This way, the desiccant that was regenerated is used to dry the gas, while the desiccant that was used to dry the gas is regenerated. Compressed gas that is clean and dry is usually stored until it is needed in the facility. Typically, containers called receivers are used for this purpose. Receivers are large tanks that store compressed gas so that compressors don't have to operate continuously. In most facilities, the demand for compressed air and other gases varies greatly, and the pressure in the compressed gas system can vary with demand. To keep the pressure from rising uncontrollably, some method of regulating the pressure must be used to control the amount of gas that is delivered by the compressor. Pressure regulating methods range from a simple on-off system to more sophisticated methods, such as the use of inlet valve unloaders. When pressure is regulated by a simple on-off system, a sensor in the receiver controls the compressor's drive mechanism. When the pressure in the receiver increases to a preset value, a signal is sent to stop the compressor. When the pressure in the receiver drops to another preset value, a signal is sent to restart the compressor. Large compressors tend to be more efficient if they operate continually. So one device that is commonly used to prevent overpressurizing the receiver is an inlet valve unloader. This is a simplified illustration of a portion of a compressor system that uses an inlet valve unloader. The unloader consists of a piston and a connecting rod, which is connected to the inlet valve on the compressor. A pressure sensing line is connected from the unloader to the receiver. Gas from the receiver fills the pressure sensing line. As the pressure in the receiver increases, it moves the piston and the connecting rod and opens the compressor's inlet valve. With the inlet valve open, the gas that enters the compressor is pushed back out again and is not compressed. When the pressure in the receiver decreases, the pressure on the unloader piston also decreases, allowing the inlet valve to move back and forth normally, and the compressor resumes normal operation. Another type of auxiliary device that prevents excessive pressure is a safety valve. If other means of controlling the pressure fail, a safety valve opens to relieve excess gas pressure that might otherwise cause personal injury or damage plant equipment. In this topic, we looked at various auxiliary devices that are commonly used with compressors and compressed gas systems. Take some time now to try some practice questions that relate to this material. The other method of water cooling cools just the compressed gas. This method involves one or more shell and tube heat exchangers. Depending on their location, these heat exchangers are classified as either intercoolers or aftercoolers. The main difference between intercoolers and aftercoolers is where they're located in the flow path of the compressed gas. Another auxiliary device that may be used along with a demister when extremely dry gas is required is a desiccant